beats are formed when two waves with same amplitude and slightly different frequencies traveling in the same direction gets superposed. This superposition leads to alternate periodic maximum and minimum intensity variations of sound. We will hear a maximum intensity of sound. It fade becomes zero, again maximum, zero, maximum, zero, maximum, zero. That's called beat formation. Now, the time interval between two maximum intensity to nearest maximum intensity or to nearest minimum intensity of sound is called beat period. Number of beats in 1 second called beat frequency. Beat frequency even reciprocal of beat period. So this is the basic idea. Now there is an expression we are arriving at beat frequency. So the first wave undergoing superposition y1 xt. For convenience, we take as x as 0 origin. A same amplitude sine omega 1t. It can be cos also. And y2 0t same amplitude. It's slightly different frequencies. Represent the two sound waves. Now, according to principle of superposition, the resultant displacement will be y1 plus y2 so when you add this, a is common, sine omega 1t plus sine omega 2t. We need to learn the formula sine c plus sine d equal to 2 sine c plus d by 2 cos c minus d by 2. So if you apply that here, 2, a is already here, sine C is omega 1t, D is omega 2t. So omega 1 plus omega 2 t by 2 into cos omega 1 minus omega 2 into t by 2. In this function, omega 1 plus omega 2 by 2 will be a high value because they are adding and getting the average. Omega 1 minus omega 2 by 2 will be a small value because you're subtracting. Out of the two variables, the main variable is the one omega 1 plus omega 2 into t by 2 because it's high value. Omega 1 minus omega 2 into t by 2 is a small variation. So we'll take that along with 2a as the amplitude. So 2a cos omega 1 minus omega 2 into t by 2 is taken as the amplitude because the omega 1 minus omega 2 by 2 into t is a slow varying term, along with sin omega average into t. This can be written as a sin omega average into t, where amplitude a is 2a cos omega 1 minus omega 2 into t by 2. Now we need to find what all time the sound intensity is maximum. Sound intensity is maximum when amplitude is maximum. The actual relation is intensity I is proportional to square of the amplitude. So whenever amplitude is maximum, intensity also maximum. So your amplitude is A. So 2A cos omega 1 minus omega 2 into t by 2 should be maximum. In that 2 and a can't change, so cos only can change. So cos omega 1 minus omega 2 into t by 2 can be either plus or minus 1. We know cos 0 is 1, cos pi is minus 1, cos 2 pi is again 1, cos 3 pi is minus 1. So cos n pi is equal to plus or minus 1. If we compare, right hand side is plus or minus 1, left hand side is cos. So within the bracket, what is that should be same? Means omega 1 minus omega 2 into t by 2 supposed to be equal to n pi. Omega 1 you can change as 2 pi nu 1. Omega 2 will be 2 pi nu 2. So 2 pi is common. Nu 1 minus nu 2 into t by 2 is equal to n pi. From this pi will go, 2 will go, we'll get ts n upon nu 1 minus nu 2. So here n can have values. Cos 0 is 1, so 0. Cos pi is minus 1, so 0, 1, 2, 3, right? You can find t0 by putting n equal to 0. N equal to 0. First sound maximum will be 1 by nu 1 minus nu 2. Putting n equal to 1, we can get t1 as 1 by if we put n equal to 0, this will be 0. So when n equal to 0, t will be 0. when n equal to 1, t1 will be 1 by nu1 minus nu2. So if you want to find the beat period, it will be difference of t1 minus t0. That will be 1 by nu1 minus nu2 minus 0. That will be 1 by nu1 minus nu2. So beat frequency will be reciprocal of beat period. The reciprocal of this time will be nu1 minus nu2. So the beat frequency is nu1 minus nu2. There was a small correction here. I told n equal to 0, I put 1. When n equal to 0, it's supposed to be 0 because when you put 0 on the top, then the term will become 0.